Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will review all of the advanced trigonometry you need for our upcoming test. So in the advanced trigonometry section, we're going to focus on the unit circle and trigonometric equations and also graphs. So let's start with the unit circle that looks like this. So it's a circle whose center is the origin in the Cartesian plane. It's called a unit circle because its radius is 1. Now, I apologize, the way that we determine angles in the unit circle is like the opposite of how we did it for bearings. Unfortunately, that's just something we have to live with. So for the unit circle, 0 degrees is the positive x-axis, and we go in an anti-clockwise direction. So it turns out, in this unit circle, sine of an angle is always the y-coordinate, cos of an angle is always the x-coordinate. What do I mean by that? Well, let's say we were going to draw an angle here that was 60 degrees. So 60 degrees is the angle made with the positive x-axis. Now, it will hit the circle at some point. It turns out that the coordinates of this point, and I'll call that point x, they are a half root 3 on 2. So cos of 60 is a half, because cos of the angle gives the x-coordinate, sine of 60 is root 3 on 2, it gives you the y-coordinate, and tan of 60 is y divided by x. So if you did that divided by that, you'd actually get root 3. So this is really helpful for finding the value of sine, cos, and tan of angles that are not less than 90 degrees. So let's say that I wanted to find the sine, cos, or tan of 120 degrees. How would I do that? I could use the unit circle. See, when we're talking about sine, cos, or tan of an angle, we're always talking about the angle made with this positive x-axis. So 120 degrees would be this angle here. We'd go around 120 degrees. Now, if we draw another line here, this triangle here and this triangle here would be congruent. Sorry that they're poorly drawn. So where would this line here that's at 120 degrees to the positive x-axis, where would it hit the unit circle? Well, because these triangles are congruent, all the distances would be the same. The only difference is the sign, and I mean S-I-G-N there. So it turns out if I call this here point K, the coordinates of point K will be negative a half root 3 on 2. So the x-coordinate's negative a half because these distances are the same. The only difference is x is negative in this quadrant. The y-coordinate is the same because these distances are the same. They're both root 3 on 2. So sine of 120 is the y-coordinate at this point, which is root 3 on 2. It's the same as sine of 60. Cos of 120 is the x-coordinate, so it's the same half, but it's now negative. And tan of 120, tan is always sine divided cos. It's just that divided by that, it will be negative root 3. So it turns out in this quadrant, between 90 and 180 degrees, if we take the sine of the angle, it's always positive, and if we take the tan or cos, it's negative. This ASTC helps you keep track of what's positive. So A means all. All of sine, cos, or tan are positive in this quadrant. So if you take sine, cos, or tan of an acute angle less than 90, if theta is less than 90, then each of these will be positive. In this second quadrant, between 90 and 180, only sine is positive. So like sine of 100 would be positive, but cos and tan of 100 would be negative. For angles between 180 and 270 in the third quadrant, only tan is positive. So for example, if you were to take sine, cos, or tan of 200, sine and cos would be negative, tan would be positive. And finally, in the fourth quadrant, when you're taking angles between 270 and 360, only cosine is positive, the other two are negative. We use this to solve equations like cos theta equals minus a half. So this notation simply means we want to find the solutions between 0 degrees and 360 degrees. So the first step is to determine where the solutions will lie on the unit circle. We have cos equaling a negative. So cos is negative in this quadrant and this quadrant. So there will be one solution here in the second quadrant and one solution here in the third quadrant. Now we know, when we just mention this, that cos of 60 is positive a half. So where will it equal negative a half? Well, we have one solution here, and that was 120 degrees. We drew a triangle so that we were making the same angle with the x-axis. So remember, this angle of this line here is not 60, it's always the angle made with the positive x-axis. So that's why one solution here was 120 degrees. So that's the solution in this quadrant. What would be the solution in this quadrant? Well, I want to have the same number, just a different sign. See, cos of 60 equals a half. So what I want to do in this quadrant is draw another triangle where, again, the angle made with the positive x-axis is 60 degrees, because this will have the same magnitude as this one here. So what is this solution here? It's not 60. We're not interested in the angle made with the negative x-axis. We want the angle made with the positive x-axis, this one here. So this angle in red is 180 plus 60. The other solution is 240 degrees. Now there are no other solutions because there's none in this quadrant, because cos is positive. We wanted cos to be negative. So we're done. All right, let's look at a harder equation now. So we're going to solve this equation here for theta. Cos squared theta plus sine theta equals 1. Now, when you have an equation that has both a cos and a sine, you need to change it. It's really hard to solve one that has a cos and a sine. We need to change it so it only has coses or only has sines. Now, hopefully you're familiar with the Pythagorean identity that sine squared theta plus cos squared theta equals 1. This works for any angle, whether acute or obtuse. So from this formula, we know that cos squared theta is 1 minus sine squared theta. So knowing some of these identities can really help us solve equations. Now you might be thinking, how does this help? Well, I can replace cos squared theta with 1 minus sine squared theta. Then I only have sines in this equation. So substituting this for cos squared theta, I get cos squared theta, which is 1 minus sine squared theta, plus sine theta equals 1. Okay, what do I do now? Well, I can get rid of the 1 on each side. Essentially, I'm subtracting 1 from both sides. I'm left with this quadratic because of the squared term. So I'm going to take out a factor here of minus sine theta. So factorizing this, I get negative sine theta outside of sine theta minus 1 is equal to 0. So we can use the null factor law. If you have something times something equals 0, either the first something is equal to 0 or the second something is equal to 0. And if sine theta minus 1 equals 0, then sine theta equals 1. Okay, now we just have to remember from our unit circle where sine theta equals 0 or 1. So from the unit circle, sine theta equals 0 at 0, 180, and back again at 360 degrees. You get that straight from the unit circle. So remember, for the unit circle, sine is the y-coordinate. The y-coordinate is 0 here and here on the edge of the circle. So it's 0, 180, and back again at 360. So where does sine theta equal 1? Well, it equals 1 up here. It's the unit circle. The radius is 1. The only time sine theta equals 1 is 90 degrees. So there are 4 solutions to this equation: 0, 90, 180, and 360 degrees. All right, let's look now at graphs. So if we want to graph y equals a sine or cos of bx plus c plus d, the graph will always look like this. It's a periodic function, goes up and down forever. The values a, b, c, and d determine where the graph sits in the Cartesian plane. So d is the midline. It's a horizontal line that sort of cuts the graph in half. A is the amplitude. It's both the distance from the midline to the peak or the midline to the trough. Now, trigonometric graphs, sine and cosine graphs, they always have a peak and a trough. The peak is always A plus D. That's the highest Y value the graph goes to. And the lowest Y value the graph goes to is D minus A. Now, B helps us determine the period. B is not the period. The period is 360 divide B. The period is the distance along the x-axis between peaks. C is the phase shift. Basically, think of the value of C being determined by where the first peak is. So you're probably thinking, okay, what does this have to do with trigonometric equations? Well, sometimes we want to use a sine or cosine function to model a phenomenon that goes up and down, up and down. And that's what we're going to do in the next question. So the depth of a tidal pool on a particular day modeled by a sine or cosine function. The maximum depth is 3 meters at 5 p.m. The minimum depth of 1 meters occurs at 5 a.m. and we're going to devise an equation to model this. So before we do that, I'm going to draw a diagram. So what we're going to do is along the x-axis, we're going to have the time, and we mean hours after midnight. So along the x-axis, for example, 5 would be 5 hours after midnight, 5 a.m. 17 would be 17 hours after midnight, it would be 5 p.m. And for y, we're going to have the depth. Y will be in meters. So we want our function to oscillate between 1 and 3 meters. So what we've got is this function that has its trough, its nadir, its low point at 5 a.m., its high point at 5 p.m., and it's going to go continually up and down like that forever. We're going to come up with an equation for this graph here. So regardless of whether it's a sine or cosine graph, the values of A, B, and D will be the same. Let's go ahead and find them. So D is the midline. It's halfway between the trough and the peak. D will be here at y equals 2. So we're going to have D equals 2. A is the amplitude. It's the distance from the midline to the trough, also the distance to the peak. The vertical distance here in both directions is 1. A is therefore 1. So how do we determine B? Well, B comes from the period. The period is the distance between peaks. It's 360 over B. So what are the peaks here? Well, it happens at 5 p.m. every day. That's when the peak occurs. So it happens every 24 hours. So we want the period, we want the distance between peaks to be 24 hours along here. So if we have 24 equals 360 over B, B just equals 360 over 24, which is 15. By making B equal to 15, that means that the peak will be every 24 hours. So the values of A, D, and B are the same, whether it's a sine or cosine graph. The thing that changes is the value of C. C will be a different value if we use a cosine graph than if we use a sine graph. Now, it's easier to find C if you use a cosine graph, because if you use a cosine graph, C is just the negative of the x value of the first peak. Now, you're probably thinking, what the hell am I talking about? Well, the first peak here occurs at 17. That's what we got from the worded information. So if I want a cosine graph, I can just set C to equal negative 17. If I wanted a sine graph, I'd need to find the value of C so that this here equals 90 degrees when x equals 17. It sounds a bit more complicated, so if you get a choice between sine and cosine graph, choose the cosine graph, because even though A, D, and B are the same for sine and cos, C is much easier to find. So putting this all together, our equation is y equals A, 1, I don't really need to write it, but I'll just write it here to show you, cos B x plus C, so here C was negative 17, plus D. This is an equation that models the information here. All right, let's now look at using this equation to solve a problem. So this is the equation that we came up with on the previous slide. Remember, y was the depth of the tidal pools in meters, x hours after midnight. So x equals 2 is 2 a.m., x equals 14 is 2 p.m., and so on. So we want to solve for when y, which was the depth, is equal to 2.5. So here is the equation that we're solving, just simply substituting y for 2.5. First thing we're going to do is subtract 2 from both sides, because plus 2 and minus 2 undo each other. So I get 0.5 is equal to cos of 15 outside of x minus 17. So now I need to get rid of the cos, and you do that by taking the cos inverse. The problem is it's not a function. Cos inverse of 0.5, you can put that on your calculator, and one answer you'd get is 60 degrees, but there is another solution. And that other solution, when we use the unit circle, would be 300. See, 60 degrees here gives us one solution. It's in the first quadrant, and we know it goes ASTC. So cos here is positive 0.5, so the other solution is in the fourth quadrant. It will occur when this angle here is 60 degrees, and so the angle made with the positive x-axis is 300 degrees all the way around. We need to solve both of these. So we have 60 equals 15 outside of x minus 17. So we can solve that easily. Divide 60 by 15, you get 4. Add 17 to both sides, you get x equals 21. Okay, so the other possible solution we get is if we have 300 equals 15, x minus 17. And we do the same thing. We divide each side by 15 and then add 17 to both sides, and we get 37 equals x. What do these two solutions here mean? Well, remember, x is the number of hours after 12 a.m. So 21 corresponds to 9 p.m. 21 o'clock is 9 p.m. Now, what does 37 hours after 12 a.m. mean? Well, if you go forward 24 hours, you're at 12 o'clock. This is 13 hours after that. This is 1 p.m. Remember that the peak here occurred at 5 p.m. So, between which times is the depth greater than 2.5 meters? Every day it's going to be between these two times, between 1 p.m. and 9 p.m. All right, I know this is very complicated and hard, but please reach out if you need help. Best of luck studying, but you will ace it because you're a superstar. Thanks for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.